Welcome. This is our talk show, Sun Talk. Thank you for coming. Today, we're going to talk about, a little bit of the rules. We don't debate. This is for open minds. Um, the idea is to um, share knowledge to attain wisdom. And today we're going to talk about artificial intelligence and how it has been applied to the Summerian tablets reading or researching, um, because because the Summerian tablets are very difficult to decipher and to read and interpret. So we're gonna look a little bit about what's going on that field. All right. So so the interpretation we're gonna be looking at various chapters, and we're gonna go piece by piece. So so basically, the Sumerian civilization flourishing in ancient Mesopotamia left an indelible mark in the course of human history, most notably through their invention of writing. Their written records, predominantly inscribed in durable clay tablets, offer an unparalleled window into the nascent stages of urbanized society, encompassing aspects of governance, economic activity, religious beliefs, literary expressions, and daily life. The sheer volume of these unearthed tablets, estimated to range from 500,000 to 2 million, represents an immense repository of historical information, much of which remains inaccessible due to the complexities of the ancient Sumerian language and the cuneiform script. In recent years, artificial intelligence has emerged as a transformative force across numerous disciplines, and its application in historical research and ancient language decipherment holds significant promise for unlocking the wealth of knowledge contained within these Sumerian records. The ability of AI to process vast datasets and identify intricate patterns offers a potential solution to limitations inherent in traditional methods of Assyriology, the field dedicated to study the ancient Mesopotamia. Given the disparity between the extensive number of tablets discovered and the limited number of experts capable of their translation and analysis, AI presents a crucial avenue for us accelerating the interpretation process and broadening our understanding of this foundational civilization. I just want to say that if people knew what I'm doing with AI, they will be very concerned. Any comments, Santiago?
No, no comments, sir.
Unveiling the past. Sumerian tablets and cuneiform. The primary medium for Sumerian writing was the clay tablet, a practical and enduring material prevalent throughout the ancient Near East during the Bronze and the Iron Ages. The inherent durability of the clay has ensured the survival of these records for millennia, offering a direct physical connection to the past. While unfired clay tablets could be recycled by soaking them in water, many tablets were intentionally or accidentally fired, solidifying them into permanent archives. The act of writing involved using a stylus, often made of reed, to press wedge-shaped impressions into the soft clay. This distinctive script is known as cuneiform, derived from the Latin words for wedge and shape. The Sumerians residing in the city-state of Uruk in southern Mesopotamia developed cuneiform around 3200 BCE. This writing system evolved from early pictograms, simple drawings representing objects, to a more complex logosyllabic script capable of recording the nuances of a spoken language. Over time, cuneiform was adopted by numerous other cultures and languages across Mesopotamia for over 3 millennia, attesting to its robustness and adaptability. The information inscribed on these tablets is incredibly diverse, ranging from mundane administrative and economic records detailing the allocation of resources and tracking goods to profound religious texts like hymns and myths, including the Epic of Gilgamesh, legal documents, school exercises used by scribes in training, and even early forms of scientific observation, such as astronomical records and mathematical calculations exemplified by the Plimpton 322 tablet, have been discovered. The practice of using seals to authenticate transactions and the existence of tablets encased in extra layers of clay for privacy further illustrate the sophistication of the Sumerian record keeping. The evolution of cuneiform from basic pictorial representations to a system capable of conveying abstract ideas and a wide array of information underscores the intellectual and societal advancements of Sumerian civilization. The sheer variety of content preserved in these tablets highlights the immense potential of AI to uncover multifaceted insights into their culture. The intricacies of interpretation, challenges for human experts. Interpreting Sumerian tablets represents a formidable challenge to human experts due to the nature of the language and script. Sumerian stands as a language isolate, meaning it has no known living relatives, which complicates its decipherment and understanding. The cuneiform script itself is a logosyllabic with individual signs capable of representing entire words, logograms, syllables, phonograms, or functioning as semantic classifiers, determinatives. This inherent flexibility leads to polysemy, where a single sign can have multiple meanings, and homophony, where different signs can represent the same sound, introducing significant ambiguity in interpretation. The extensive number of distinct signs, initially numbering in the hundreds and later stabilizing around 400, along with the variations in their shapes and meanings across different historical periods and geographical regions, further compound the difficulty. The traditional methods of interpreting these ancient texts are time-consuming and labor-intensive, demanding years of dedicated study to acquire the necessary expertise. The number of scholars proficient in both Sumerian and Akkadian, another language commonly found in cuneiform tablets, is limited, creating a bottleneck in the translation and analysis of vast number of unearthed artifacts. Moreover, the interpretation process can be subjective, with the potential for disagreements among experts regarding the precise meaning of certain signs or the overall context of text. The physical condition of the tablets themselves often presents additional hurdles, as fragmentation, damage, and weathering can obscure the inscribed signs, making decipherment even more challenging. Given these considerable complexities and limitations of human expertise, the application of automated interpretation methods, such as those offered by artificial intelligence, holds significant potential for advancing our understanding of the human civilization. A new era of understanding, AI in historical text analysis. The application of computational methods, including artificial intelligence, to the study of ancient Mesopotamia languages and texts marks the rise of computational assyriology. AI is increasingly transforming the analysis of historical documents in general, offering new avenues for deciphering lost scripts, translating ancient languages, and extracting valuable information from vast quantities of textual data. Natural language processing (NLP), a branch of AI, empowers systems to analyze and understand large volumes of text, identifying underlying themes, extract key entities and relationships, and even generate summaries, facilitating the extraction of knowledge for unstructured historical data. Machine learning (ML) algorithms can identify subtle patterns and anomalies within historical datasets, revealing trends and correlations that might be difficult for human researchers to discern. Furthermore, computer vision (CV) techniques enable AI to analyze and interpret historical images such as photographs and ancient scripts, allowing for the identification of individual characters and potential reconstruction of damaged and fragmented texts. The prevailing view among researchers is that AI should serve as a powerful tool to augment rather than replace the expertise of human scholars in the interpretation of ancient texts. AI capacity to handle the initial, often tedious stages of translation and analysis can free up humans experts to focus on more nuanced interpretations, contextual understanding, and the identification of significant historical discoveries. This synergy between human intellect and artificial intelligence promises to unlock new levels of understanding from vast archives in the world.
Actually, I have a comment regarding to all that you just read.
Right.
Something that kept was brought to my mind. Our current society, if we project this 10,000, 5,000 years in the future, we don't have anything written in stone. In other words, we don't have anything that is going to prevail.
I think we're in trouble.
So at least we know that the ancients were written things in stone.
Yeah.
We don't.
They were smart. They were smart.
They were smarter.
Yeah.
We have everything digitalized, and probably the only things that will survive are the ABC toys that we were playing with when we were kids.
Yeah.
They were written in plastic. That there's basically only the alphabet, but no words or no nothing. I mean, so that was something it's something to think about.
Yeah.
I guess.
Yeah. I totally agree.
Sorry for the interruption, but
No.
I wanted to bring that up.
That was perfect. All right, decoding antiquity, the specific AI projects and initiatives. Early explorations into the application of AI to cuneiform script have paved the way for more sophisticated projects. The development of comprehensive digital corpora and databases of cuneiform text, such as the Open Richly Annotated Cuneiform Corpus and the Cuneiform Digital Library Initiative, has been crucial in providing the necessary data for training AI models. Several research initiatives have focused on utilizing neural machine translation models similar to those powering modern translation tools to automatically translate Akkadian cuneiform into English. Projects like Babylon Engine have developed online platforms to provide public access to these AI-powered translations. The accuracy of these AI translations is often elevated using metrics such as BLEU scores, with some models achieving scores indicating a useful level of translation quality of Akkadian. Recognizing the unique challenges posed by the Summerian language, researchers have also undertaken initiatives specifically targeting its interpretation using deep learning approaches. These projects have focused on tasks such as automated glyph prediction, where AI attempts to predict missing or damaged cuneiform signs, and transliteration, the process of converting cuneiform signs into the Latin alphabet, the creation of specialized datasets like Summerian Tablets, which pairs Unicode representations of Sumerian cuneiform glyphs with their corresponding transliterations, is essential for advancing NLP research in this area. Furthermore, computer vision techniques are being employed to enhance the recognition of cuneiform characters for images of tablets. Models like ProtoSnap have been developed to precisely align prototype characters with the variations found on actual tablets, improving the accuracy of optical character recognition. The use of 3D models of tablets combined with AI algorithms offers a promising approach to overcome challenges related to lighting and viewing angles that can affect the clarity of the photographed inscriptions. The growing number of dedicated projects employing diverse AI techniques highlights the increasing commitment to leveraging computational power for the interpretation of the Sumerian tablets. Well, I want to make a huge parenthesis here.
Yep.
This is, I mean, it's just mind boggling that the first, or maybe not the first, but one of the first civilizations on Earth was this sophisticated. I mean, it is just,
Oh yeah.
it is
Absolutely.
just stunning. So that,
Just the math, the way they were doing math. I
yeah,
mean,
yeah.
it
So
was.
the question is, who taught them? Because somebody taught them. They didn't develop knowledge just because yes.
Right.
So in the same tablets of the Sumerians explain the history of way back. I mean, how mankind was created. So in the Sumerian tablets, which is different from religion and precedes religion because it's older,
Hmm.
they I'm gonna say this very quickly. They explain how um, a very advanced civilization came to Earth looking for gold, and they needed to extract the gold. So, but they needed workers because their workers didn't want to do it. So, so they were very advanced, and combining the Homo erectus, which was the most evolved, how do you call them?
Humanoid. Humanoid.
Humanoid, with their own DNA, they created. It's I think it's six or
The
seven races. Um, so
races or species.
no, human races. They created the white, the black,
Hmm.
the yellow, the red, the natives Americans, and I'm missing something. So yeah, they created the different races that are not explained in the religious books. The
Hmm.
religious books, they don't explain how did we get, and they don't explain why slavery goes back so far. And that is
Hmm.
because humans were created to be slaves, to extract that gold. So, to extract that gold for this advanced civilization that their world was dying and they needed the gold. Um, and they were the ones that taught the Sumerians all this
Yes.
advanced knowledge, the writing and the math and civilization and urban and crops and how to grow crops and at a large scale because these were large populations and they needed to feed them. So they taught all of this to the Sumerians, and they we still use some of their math, right? The 360 do we use? We use the 60 and the 360, um, like the minutes and all of that
Mhm.
was Sumerian.
Yeah, the base
Base 60.
60.
Yeah. So okay, that was my parenthesis.
Yeah, that's huge. Parenthesis. That
Yeah,
makes total sense. Yeah.
if you want to learn more about this, look at the library of Sontalk, and we have a lot more episodes. We've been talking about pretty much everything. The AI toolkit: natural language processing, machine learning, and computer vision. The interpretation of Sumerian tablets relies on a combination of AI methodologies, each contributing unique capabilities to the task. Natural language processing (NLP) techniques are applied to analyze the linguistic structure of Sumerian text, including tokenization, breaking the text into meaningful units, morphological analysis, identifying word forms, syntactic analysis, understanding sentence structure, and semantic analysis, interpreting meaning. The agglutinative nature of Sumerian, where words are formed for adding prefixes, infixes, and suffixes to a root, and the historical lack of dependency rules in Sumerian grammars, present unique challenges for a standard NLP tools. However, the transformer architecture, a type of neural network particularly effective in translation tasks, has shown significant promise in its application to Sumerian. Machine learning algorithms are employed for various tasks, including language identification, distinguishing between Sumerian and other languages written in cuneiform, dialect identification, recognizing variations with Akkadian, within Akkadian, and the classification of individual cuneiform symbols. Language models trained on existing textual data. I'm going to stop here. And Santi, can you explain language models? You're an expert on that.
Yeah. Well, the language models basically um, is is a technique or is a set of algorithms that understands the human interpretation. So really, the language model is to be able to interact with a machine like that machine is a human being. So when you're if you're using tools like ChatGPT, these tools are returning in a friendly way to you. They're
Mm-hmm.
replying back to you,
Mm-hmm.
and that is basically a language model. So there are more advanced language models. Like, I mean, ChatGPT is one language model, but there's so many others. There's a O1, and there's some specifically designed language models, and those language models are designed specifically for certain needs. So let's say you have a language model that is trained to be a doctor. For example, IBM uses Watson, and Watson is a language model that is trained to be a doctor or an
Mm-hmm.
engineer, or so it basically they talk in those terms. So that's pretty much what it is.
Excellent. All right. Computer vision. Thank you. computer vision plays a critical role in processing the visual representation of cuneiform script on the tablets. Optical character recognition (OCR) techniques are used to automatically identify and transcribe the cuneiform characters into machine-readable format. CV is particularly valuable for deciphering text on fragile and damaged tablets where human eyes may struggle to discern the markings. The use of three-dimensional models of the tablets enhances character recognition by providing more detailed surface information and allowing for comparative analysis across multiple tablets. The integration of these diverse AI methodologies is essential for a comprehensive approach to interpreting the complexities of the human tablets. Current progress and pitfalls, successes and limitations of AI interpretation. Significant progress has been made in automating the translation of cuneiform text, particularly the Akkadian, where AI models have demonstrated considerably accuracy, especially with formulaic texts such as royal decrees and omens. High levels of accuracy have also been achieved in the transliteration of cuneiform script into Latin characters, a crucial step in the interpretation process. The creation of large AI translated corpora of cuneiform texts, such as the AI cuneiform corpus, has dramatically increased the amount of Sumerian and Akkadian material accessible to researchers and the public. Despite these successes, limitations and ongoing challenges remain. AI models currently exhibit lower accuracy when translating more complex literary and poetic texts, sometimes producing hallucinations. So, how we can explain? Okay, here. Meaning they generate translations that are syntactically correct but completely unrelated to original meaning. Why did they put the name hallucination? It's just giving the wrong thing, right?
Yeah. It's a bad interpretation, pretty much.
Yeah.
It's not. Yeah.
Yeah.
What I get from there is that basically we or this translation are based on an initial knowledge, okay?
Mm-hmm.
But that initial knowledge is based on, I think you mentioned that it's 400 original tablets or something like that, 300 something tablets.
No. The 400 is the language. The 400.
Oh, the language, the characters.
The characters.
Yeah,
And the tablet is like 2 million.
But it's still, yeah. So, but it's still, those characters are based on interpretation
Right.
that originally were made by a human being.
Right.
So,
right.
So if the interpretation was incorrect originally, then the translations of those tablets into
right.
is might be inaccurate. Or that's
right.
basically
which is the base. Which is the base and could be less, could be more.
Correct.
I mean, we don't know.
But the interesting thing is that actually you mentioned neural networks and all of that. The neural networks will basically is used for learn by itself. So basically, it takes one of those cuneiform characters and it will interpret it in one way and then try to interpret it in another way, and then try to interpret it in another way until it finds an actual meaning.
Right.
So it learns by itself. This basically has a lot of cycles to be able to to learn, basically.
And we should mention that this is all with digital technology. In an episode in our library, we talked about the quantum computing, and when this is done soon or I mean, in the future with quantum computers, it's gonna be way more powerful, way
Oh
more
yeah.
powerful. Um, okay, where I was. Handling long and complex sentences and grasping the broader context of the text also presents difficulties for current AI models. The, the availability of sufficient high quality training data, particularly for Summerian, remains a challenge. So let's talk about that training data. You do this,
Hmm.
Santi. So how tough is to train? Is the
It's
training?
difficult.
Is the training?
It's yeah. I mean, first to train an AI system, you really need to know things. So I mean, let's just start simple. Let's assume we have a handwritten letter.
Mm-hmm.
Okay, and you write a letter. I write another letter that means totally different things, but it's a manuscript. Okay, and then we want to put this to an AI. You write the letter A in a way that is different than the one I write. Okay, but they are all based on the same model. So let's say we have the the um, the Latin A in uppercase and the Latin A in lowercase.
Mm-hmm.
Okay,
Mm-hmm.
so now let's say you have this same letter in the same text that was written in one way, and I have another letter that is written this way in a whole different way. So we have, for example, you're using a script. What is the name of that? The an italic version of the
Right. Right.
of the handwrite, and I have the typical handwriting. So, or a mix of it. Okay.
Mm-hmm.
Sometimes actually I do mix the two different ways of writing. So
Right. Right.
when and let's say we have a system that is taking a picture and scanning those letters, it tries to interpret what uh, each character means. Okay, and let's assume this AI system doesn't know anything about it.
Mm-hmm.
So you need to start feeding this with the more and more and more letters and more manuscripts and more things to let it cycle on top of it
Mm-hmm.
until it has a meaning. Okay.
Mm-hmm.
Um,
Wow,
uh,
this is very important. So
yeah,
this
exactly.
is
So
this is
so
the
so
key. This is the key. Yeah.
that's the key. So
Yeah.
really, it's a level of cycle. So
Yeah.
until that is feed with knowledge, okay? Because right now what we're doing is just feeding the AI system with knowledge.
Right.
Now you have your AI environment now has or your AI model language now knows. Oh, I can interpret manuscripts,
Mm-hmm.
okay?
Mm-hmm.
And the manuscript means this.
Mm-hmm.
Now the those manuscripts, if the person who's feeding them knows them, can validate this. But the thing is that what if we don't know what they mean? Okay,
Mm-hmm. Mm-hmm.
which is just put it this way. Let's is we are reading these tablets now, the Sumerian tablets, and then we're trying to interpret what it is, but we don't know what the characters mean. We are assuming the characters mean something. Okay, we assume things there. So the system needs to start cycling all of the knowledge until it finds a meaning,
Right.
and that meaning is the knowledge, and that is what we are based on the truth. It's really hard because that truth might be not real,
And the
might be an
other
hallucination.
And the other problem, let me just interject there. The other problem is that there's no way to compare it to something else. So
Exactly. Yeah,
so
that's my point.
yeah,
That's exactly my point. Yeah,
yeah,
yeah. There's no way to compare that.
yeah,
So we're assuming it's correct until there's another manuscript or
yeah.
another tablet
Yeah,
that
you can
arrives
compare.
and breaks everything.
Yeah, yeah. This is so
So
hard.
yeah,
This is so hard.
it's really hard. It's
Yeah,
really hard.
yeah. All right. So let's continue. Um, where I was.
But actually, you brought something very important in the previous statements about the quantum computing. It, basically, the power of quantum computing is like comparing. If you assume a current computer technology that we have is uh, a little uh, ping pong ball, okay? Uh, Basically, the computer, the quantum computing is about the size of the sun. Okay, so that's really the comparison. Is you're comparing a ping pong.
Millions
Oh no,
of
it's
difference.
it's yeah, it's super different. I mean, it's extremely fast. It runs in parallel in multiple parallelisms.
Can we
It's
say
crazy.
can we say that that's the power of nature? I mean, that's the kind of processing that nature does. I mean, that's the way I see it. The way
Probably I don't yeah.
because quantum, as we remember, is very different than digital. Digital is just zeros and ones, and
Yeah,
quantum is particles and waves, particles and
yeah. Well,
waves, and that's nature basically. So
right. And one interesting thing about quantum is that there's no concept of one zero.
right,
It's the concept of whole.
whole,
And the thing is that this whole could be one or zero at the same time.
right.
So, yeah, it's something mind blowing. Hard to explain.
Well, I can say something. We can be extremely intelligent and extremely dumb all at the same time.
Uh, which happens all the time.
Yeah, happens. I see it every day.
Yeah,
All
yeah,
right,
yeah.
let's continue. Handling long and complex sentences and grasping the broader context of the text also presents difficulties for current AI models. The availability of sufficient high quality training data, particularly for Summerian, remains a challenge, which is what we just said. And inconsistencies in existing manual transliterations can further complicate the training process. The inherent ambiguity of many cuneiform signs and the polysemous nature of the Sumerian language continue to be significant hurdles for AI interpretation. Um,
Leo, something that you just mentioned is like each character, a cuneiform character, has different meanings.
right.
If you put it this way, it's quantum.
Uh-huh.
It's
Right.
quantum. I mean,
Right.
yeah,
They knew
it's
what they were
basically
doing. Yeah.
exactly.
Yeah. Consequently, there are ongoing concerns regarding the complete reliance on purely AI driven translations, underscoring the continued necessity of human oversight and validation to ensure accuracy and contextual relevance. I want to say that this applies to every field on anything the AI is doing. It needs this human oversight. I don't know why people think that AI does everything.
No, no,
It doesn't.
it's just,
It doesn't.
it doesn't. It doesn't. Yeah,
It is not perfect. It helps a lot, but someone has to check what it's doing, basically.
exactly. Yeah, somebody needs to validate.
Yeah. Expert opinions, perspectives from Sumerology and computational linguistics. Experts in both Sumerology and computational linguistics largely view the application of AI as a valuable and promising development for the field. There is a general consensus that AI can serve as powerful collaborative tool, significantly accelerating the initial stages of translation and analysis for Assyriologists. The prevailing model emphasizes a human machine partnership where AI assists human scholars without supplanting their critical expertise. Many experts anticipate that AI's ability to process and analyze vast untranslated corpora of Sumerian tablets will lead to new and significant discoveries in our understanding of Sumerian history, society, economy, and scientific knowledge. AI's capacity to identify subtle patterns and connections with the data may also reveal insights that human scholars working independently might overlook. However, there is also a degree of cautious optimism among experts. They recognize the current limitations of AI models, particularly in handling the linguistic nuances of ancient languages and the potential for generating inaccurate or nonsensical translations. The importance of transparency in how AI models arrive at their interpretations is frequently highlighted, as this is crucial for mitigating potential biases and ensuring the responsible application of these technologies. The need for continued human involvement in validating AI generated translations and interpretations remain a key point of agreement among experts in both fields. Conclusion: the future of AI in illuminating Sumerian civilization. The application of artificial intelligence to the interpretation of Sumerian tablets represents a significant step forward in our ability to access and understand one of the earliest forms of written communication. The progress made in our automated translation, particularly for Akkadian, and in the transliteration of cuneiform script demonstrates the potential of AI to enhance and accelerate the work of Assyriologists. The creation of large AI translated corpora has already broadened access to these invaluable historical records. However, challenges remain in fully automating the interpretation of complex literary texts and in overcoming the inherent ambiguities of the Sumerian language and in cuneiform script. Continued research and development are needed to refine AI models, improve their contextual understanding, and minimize the occurrence of translation errors. The creation of high quality standardized datasets for training AI models is also crucial for future advancements, and continued focus on the integration of different AI technologies, including NLP, machine learning, and computer vision, will likely lead to more holistic and accurate interpretation tools. Furthermore, will likely lead to more holistic and accurate interpretation. Uh, Furthermore, addressing ethical considerations and ensuring transparency in the use of AI are paramount for responsible innovation in this field. The future of Sumerian tablet interpretation lies in the collaborative partnership between human expertise and the computational power of artificial intelligence. This synergy holds the potential to unlock the vast wealth of knowledge contained with these ancient records, offering unprecedented insights into the origins of development of human civilization and reshaping our understanding of the distant past. My goodness. Um,
One thing that is interesting here is that the ones who are defining or designing those 400 cuneiform characters have different meanings is us, okay? The human beings. So really, we're assuming that each cuneiform character might have multiple interpretations,
Right.
but we might be wrong. I mean, it's possible that there's some variations,
Well,
minimal variations that we haven't noticed, or
did you see? Did you see before and after the James Webb telescope deployment? Did you see what happened once they saw what the James Webb was returning?
oh yeah, yeah.
That all theories were wrong.
Exactly. Yeah,
They were like, all theories are wrong. So yeah, take everything about Sumerians with a grain of salt because we
right.
don't
That's
know.
right.
We don't know. I mean, we're trying to do our best. So,
Hmm. With
but
what we know.
yeah,
But
with what we
but
know.
there is a huge lesson learned here. It's that we have to do something about our current civilization, because really we are gonna be lost in history. I mean, if 10,000 years from now, uh, they're gonna be still talking about the Sumerians, not about us. We basically didn't exist. So
um,
really, it will be interesting to have. Actually, I heard that some a company in Germany there, or not a company, a person in Germany, it's using like a vault uh, in a cavern in a cavern,
mhm,
and he's writing tiles.
right.
Uh, with some knowledge. I mean, like Pythagoras or geometric calculus and mathematics and some writing some of the novels, etc., written in clay, so in ceramic tablets. So that's something that's probably based on this, but it has to be more massive, and it shouldn't be done by one person or one. It should be something that needs to be more. Um,
So let me
Globalized.
let me make a commercial of my company here. So so the concern about the future, right?
Yep.
So once we realize that the next frontier for humanity is not really first the space, but unleashing the infinite mind of mankind, which is what Gawk is intending to do. Um, Teaching about knowledge, rational and intuitive, and converting and igniting intuition in humanity. This our civilization is going to be so advanced and so powerful that we can't. I mean, I can say for certain that we can't imagine because it's going to be nothing mankind have ever seen in its history. So, if you want to take a look, go to gawkc.com and click the logo and read the summary. And it's a summary written by artificial intelligence about the foundational 4 books for Gawk, and it gives you a pretty idea on how we are going to do that. So, so it's interesting that we're talking about the future, and the future will start soon. So I hope that we can move on.
Very good. Very good.
Are we good? All right. Thank you, Santi. I'll stop the recording and I'll post it tonight.
Thank you.
All right. Thank you.
Have a good night.